I want to introduce you to our first tutor for the day, Artemiy. He is a data architect at independent consultant. He will hold the data engineering in the AI era, building a robust foundation for AI applications tutorial. Hope that you'll enjoy, and Artemiy, you can now start with the presentation. Good luck.
Thank you. Thank you. So let's begin. I'm going to share my screen, and this is going to be, yes. And here it is. And yes, can you see the slides?
Yes, we can. Yeah.
Sharing. Okay, so let's begin. The title of my talk, tech tutorial, is Data Engineering in the AI Era. So what we're trying to achieve is to build a robust foundation for AI applications. So a couple of words, just a disclaimer, all the opinions are my own, and this is for educational purposes only. But anyways, you can always ask me any questions on this talk. So I've prepared a lot of slides today, and just a couple of words about me is, so I have more than 10 years of experience in data. I've been employed with the roles as a data engineer, data architect, and consultant. So what I'm currently working with is a modern data stack, modern data warehouses, data platforms like Snowflake, Databricks, ClickHouse, extract load tools, transformation tools like dbt, data clouds, cloud platforms, etc. So let's begin with the tech tutorial, and the main goals. Our main goals are, we'll try to explore ways of building robust data pipelines. And then it's going to be practice oriented, like a case study, step by step. It's all distilled knowledge from my experience, what I've been working with, the problems and issues I've been solving. And here's in this talk, I'm just going to share the distilled knowledge with you. All right, so just an overview, a brief, we're going to discuss business deliverables and outcomes, first of all. And then we'll talk about data ingestion. Then we'll proceed to data transformation and data operations. We'll not cover anything related to BI tools or ML algorithm data science aspects deep. It's going to be out of scope of this talk. So just get prepared and let's begin. So first section is called business deliverables. So it's about when we talk about AI, the most important things for us, I'll name them, is the opportunities you can identify. So be it competitive advantages. Secondly, it's the way you can do it. So are there any technical capabilities of achieving these goals, of achieving these opportunities, making them happen? And third, how fast can you ship it? It's about time to market, between the idea and the feature released to production, actually. All right, I will name a couple of examples I have identified, so namely these competitive advantages, opportunities. Let's just get some examples of it with the pictures, I suppose. So first would be summarizing data on dashboards, key metrics, reporting purposes. For example, if you're a manager or a leader and you're preparing a report for a weekly review, weekly business review meeting, this tool comes very handy. So you get a dashboard and you get a automatically generated text with a summary of what's been happening to your business, how you're progressing on your goals, the dynamics. That's number one. Pretty interesting. Number two, leveraging AI to query data from your data warehouse, from databases. It's been years, I think decades of SQL language dominating this area. So SQL is the lingua franca, most common language to query databases to get results, responses to your questions. And right now, you can leverage AI to query these data. So you can prompt with the natural language and get results from database. It's possible, becoming possible. But here are some input you have to achieve to do this. Third is about identifying personal identifiable information, so sensitive data. Sometimes you've got to follow the regulatory rules and laws, and you cannot expose sensitive data. It's even better than you don't use it at all. You don't sync it from operational data source to data warehouse. So identifying such information becomes very useful and handy in doing it automatical way. Next one is preparing tailored and personal communications with your CRM system, with your customers, just in time, emails, push messages, call to action with the perfect context and the perfect time. So that becomes reality with AI capabilities. Next one is recommendation systems. Next best offer, something that's granularly picked to you individually, that increases the opportunity you will buy it, you will add it to your cart, and you will increase the check and proceed with this order, for example. Next one is detecting fraudulent orders and transactions before they happen, before something bad happens. So that takes a lot of input, attributes, traits, events, and the time when it's happening. So it's got to be real-time scoring, some kind of a scoring system that acts at the moment something is happening. Right. So all of these examples I've mentioned, they are all based on a solid foundation, solid data foundation, which makes it possible to create, possible to build advanced AI applications. And so I named them as the data ingestion, it's data transformation and modeling, and data operations. So if we have all of these as a foundation, we can build something valuable, something of a high value to our business. Right. So let's proceed to section number 2. It's about data ingestion. It's going to be interesting, and we will start with classifying types of data sources. So first of all, there are databases. There are multiple databases of varying structure and specifics, but relational, non-relational, semi-structured data. Secondly, there are events or clickstream or stream of like behavioral data. Third, there are third-party APIs. So some services that provide you with the relevant data, for example, currency exchange rates, and then weather forecasts, and etc. And fourth group are files. It could be local files, it could be files stored in your data lake, shared by multiple people, or it could be even Google Sheets. Right, so we will focus on the first two entries, databases and events, clickstream, which comprise the, I would say, the large portion of data of any company, and it's the hardest one to set up and configure. So from the first glance, I would say to ingest such data, I would use software as a service. There's an effortless option for data ingestion. So you just pick a provider, you subscribe to some sort of a plan, pay some money, provide with the credentials, and you get this data populated in automatical way. But there are some drawbacks. There are some problems and issues with that. On this slide, I name a couple of tools I have experience with, and I've tried them. So what's the problem with this approach, software as a service? First of all, it's a limited number of features and supported connectors possibly. So you're only limited to what these particular provider gives you the opportunity to use. Second, it's most of the time it's take it or leave it approach. So no source code available, it acts like a black box, and you're limited, you're restricted to use the features which are supported, and that's it. And third one is about money. So your contract price is going to be increasing only with the time. So you're only going to add more data sources, use more features, and that's going to only increase your contract price. So that's the key drawbacks. Probably there are some more, but that's quite enough for us to build something new, to research. And we will begin with the CDC's Think for Databases, which is change data capture. So I will name Debezium. Debezium is an open source platform for change data capture. So let's name it. The core features. First of all, it's real-time data streaming from your source connectors, source databases. And it supports multiple types of databases. Most popular ones are in the list. So it's Postgres, MySQL, Microsoft SQL Server, MongoDB. Then it's fault tolerant and scalable architecture. So it scales with your, I would say, Kafka cluster. So the number of Kafka Connect nodes, you have number of Kafka nodes. So it scales horizontally, it scales well, and it's fault tolerant. Then it handles your schema evolution. So it's a very common concept. So data is never static, it's dynamic, it has dynamic nature. Something is constantly changing. In terms of database, it could be altering data types and a list of columns and changing column names, and that's etc. Then it's got Debezium is built on top of Apache Kafka project, so it's very useful and handful to integrate with Apache Kafka, which is a distributed log and well-known leader and commonly used platform. So just a brief picture of how it works. From left to right, we see the MySQL and Postgres source databases. Then we have these Debezium connectors, which read replication log write-ahead log for Postgres, and I would say uplog for MongoDB. So the names are different, but the concept is the same. So Debezium reads replication log and writes data to Apache Kafka to multiple topics. And then from Apache Kafka, you can run sync connector to write this data to any destination of your choice. It could be Elasticsearch, it could be a data warehouse, it could be other message queues, and etc. So I will give you, since I've done this this task, and I've put a lot of effort into this, and I've researched a lot and tried different things. I can share with you the list of hints, setup hints for the Debezium source connectors. So let's name them, and then I will give you some more details on each of this hint. So you would want to leverage distributed and parallel sync mode. So you would, since you have probably you would have a cluster database, and you would want to use all the resources available to keep up with the changes, ongoing changes. Then I would suggest you to limit data synced to relevant data. It could be a database, it could be a collection or a table, or it could be even you can provide column names which you want to sync. Third thing is topics auto-create features. So Debezium can create topics in Apache Kafka automatically based on their configuration. You can provide this configuration. I would not suggest to trigger initial snapshots. I would suggest to never do it, because there's a really powerful feature of signaling and launching incremental snapshots, which are way better than blocking snapshots. Then I would suggest you to configure retries, because errors like network error, connection not available are common, and retries give you the fault tolerance just in case of transient errors occur. So you would still go on if something for a minute glitches or goes wrong and then goes back. And then I would say error logging is a mandatory thing. So you would want to tolerate errors. So you'd want to go on your replication, but you would capture them and analyze them and take action. Right. So let's try to get some more details. So leverage distributed and parallel sync mode. I already said that you can configure number of tasks. Then you configure number of partitions to write. So I would choose the number of partitions as the number of Kafka brokers you have. So that's the parallelism thing. And I would also sync it with the number of MongoDB shards. So in case you're using MongoDB, you would want to align it with the number of shards to ensure parallel distributed mode. Right. Second one, relevant data is also configured with the properties file. Every kind of a Debezium connector is configured with its own properties file, and you can include additional properties. There are mandatory and there are optional properties. So to limit the amount of data to on the relevant data, you would provide a database, a collection list, and a field list. So you can either exclude or include. That's it. Number 3 is a topics auto-create feature. You can configure it a really flexible way. So starting with the replication factor, that's the number of data copies you would end up in your Kafka cluster, number of partitions, and policies, like a cleanup policy. You would want to delete your data after a certain period of time passes, or you would want to compact your data. For example, if you have multiple entries for the same key, for the same identity, then you would want to compact your data to maintain the latest row only, the latest snapshot of this key. And yeah, and the last one is about compression type. So you would have an option to compress your data on disk, so to keep your storage effective. So that standard is the property on the screenshot. Right. So what about the snapshots? Debezium works. It contains 2 ways of replicating data. So what it does, it performs an initial snapshot of your data, what's already written, what's already contains in your database, and then it begins to stream your uplog, tail your uplog, and that's the part 2 is about streaming changes. So I would recommend to skip initial snapshots on your production databases, because number 1 reason is it's a blocking snapshot and it can take a lot of time. And if something goes wrong, you would need to begin from scratch. Then second reason is about you probably won't need the whole history depth of your data. You would probably need a couple of years at maximum, or for the largest tables. And in that case, you would better trigger incremental snapshot. I will tell about it a couple of slides later. So my suggestion is to keep snapshot mode with no data. So don't perform any initial snapshot. Just go on with the schema capture and with streaming data. Then it's about signaling, which is really powerful feature. You can signal Debezium connectors to do anything, to perform an initial snapshot, blocking snapshot, incremental snapshot, stop it, or you can even set up your own actions. So to set up your signal channels, you would provide some sort of configuration. So the channel could be Kafka or source database. So you would either insert a row into a source database table, or post a message to your Kafka topic, specific topic. So there's a collection, which is the name of a MongoDB collection for signaling, and Kafka topic for it. So pretty simple. We'll proceed to the examples further. Configure retries. One more interesting thing is about being tolerant to transient errors. Like I said before, most of the time it's about connection networking errors. So something goes wrong, the connection is lost for a minute, for a couple of minutes. You would want to go on as soon as the connection is established once again. So retries and delay and backoff are configured easily with Debezium properties. Then errors. Certain source database rows or collections may produce errors, so they won't be replicated. But in case, but by default, these errors cause the connection to stop. So the connector will stop streaming everything. So you would end up with no data, with the stale data. So I suggest you to tolerate all the errors, but log them. So you would log them, include message, and include row itself. So that's the way you can identify what is wrong exactly and how can I fix it. But on the other hand, the streaming, the data sync, it goes on, it proceeds. So like imagine you would have 1% of invalid or error-prone rows entries in your database, but 99% or more are really valid and okay. So why would we end up with an error? So I suggest tolerate all the errors, however, log them. Always log them. Yes, let's proceed to the second part. It's about sync connectors. My sync connector is Snowflake. Snowflake integration with Kafka, sync connector. That's my choice because I'm using Snowflake as a destination. So Debezium for source connectors and Snowflake for destination. But you may want to use JDBC connector or any connector for your specific database of your choice. For example, ClickHouse connector. So here are a couple of hints for setting up sync connectors. Let's just proceed and I will comment on this. So you would ensure a consistent naming for your topics, as your topics will become target database tables. So these tables, well, my convention is to have a prefix of a database and then table name. So I will just use a built-in transform with Kafka Connect, which is the root. So I would have a regex and replacement with these placeholders, and I would finally end up with fancy and convenient table names, topic names, which eventually become table names in Snowflake. So I can identify which source is this table originated from. Right. Number two is adjusting settings for optimal performance. I'm focusing on these three options because they're most common and most impactful. So that's about the flush time and the count of records, so the batch size or size in bytes before data is flushed to data warehouse, to Snowflake. So that's the way you control how fast and frequently your data is flushed into database and what's the latency would be. But on the other hand, the more frequent data writes you trigger, the more money it may cost to you. So it takes more compute resources. So if you're not chasing any real-time sync manner, you would probably want to write data in micro batches, like 5 minutes, 10 minutes would be probably okay, and will be cost effective in that case. Right, next three, new record state extraction for Debezium messages. So Debezium messages is pretty, has its pretty complex structure. So it has a lot of metadata included, and it has before and after state. Since it is a log, it's a change log, there's a before and after. So pretty complex structure, but we would want to have the final state, the after state. And for these purposes, there is a built-in single message transformation in Debezium and Kafka. So it's called new record state extraction. So you would want to extract after state. This can be applied with the properties file, and I would recommend you to include relevant metadata fields. So you would end up with the after state, but also include an essential Debezium metadata. And I name it. So it's about an operation, whether it was create, update, delete operation. You would want to capture source timestamp, so timestamp when the operation occurred in source database. Then it's about Debezium timestamp, when the Debezium captured these or read this log entry. And the difference between these timestamps could be your latency of your pipeline. Then it's about the flag, which indicates whether it was a snapshot read, which source database is this, which source collection is this, and useful thing about order. So sometimes a transaction can update multiple rows or update a single row multiple times. So there's a history, a track of changes with this row. So odd is the ordinary number, which indicates the order of the operations performed. So what's the first, second, third one? If you order this the ascending way, you will get the latest, the final state of a row in your database. So you would want to have it for deduplication purposes. I will show a little bit later. Then it's about schematization thing. Snowflake allows you to create tables automatically. It's super feature, very useful. I would suggest, I would advise you to use it with Snowpipe streaming. So schematization allows you to populate columns with the specific data types automatically without doing it manually, without manually guessing schema and creating tables in advance. Right. One more thing, interested and very curious. I've got a lot of errors with this, got a lot of problems. It's about arrays. So syncing arrays from source database to Kafka incurs a lot of tricky things. So in MongoDB, you can have an array with the elements of different data types, arbitrary data types. So it's allowed, but in Kafka, it's not allowed. So to further proceed with the row, to replicate it, you would need to set your array encoding to document, which is the second picture. So your array elements become documents. So document number 0, number 1, number 2, and etc. So it's not that fancy as an usual array we're all used to, but that was the only way for me to replicate MongoDB arrays. So it's the setting I have by default. And by the way, Snowflake allows you to handle such an array representation easily. Not a problem at all. Then dead letter queue is a feature which allows you to capture error events. So certain rows which cannot end up with the destination written to a sync connector to Snowflake, they would end up with a specific particular topic in Kafka, which is called dead letter queue. And this particular topic can be replicated on its own without a schematization. You can query it in a Snowflake itself. So there was something wrong. Please show me, is that letter queue, is this empty or not? And if it's not, what's really wrong with my data? What's wrong with this particular table, collection, or field? And all the metadata, error log, reason is included. So you would need to capture your errors with that letter queue. So I suggest you to use it. Right, we've ended with the CDC data stream and proceeding now to event tracking. So I've chosen Snowplow, a platform for event tracking, due to a couple of reasons. First one is real-time event tracking. So the latency could be seconds or minutes between the actual event happening or a person, a customer doing something on his endpoint device, and you're querying this data in your data warehouse. Number two is a customizable event schema, because sometimes you would need to provide your custom taxonomy for your events, not just get something out of the box, but do something more complicated, do some arbitrary event tracking. Then it's cross-platform. Snowplow's got multiple trackers, different kind of programming language across multiple platforms, web, mobile, server-side applications. It's scalable and it's open source. It's got, it's actually got a paid subscription, which is fancy with the UI, but it's also got its open source core version. It allows you to use it and customize on your own. With the Snowplow, you've got full data ownership, full control of what's going on, what's tracked, and how it is stored, where it goes, and how you handle and proceed these events. And integration, Snowplow, it fitted perfectly with my current technology stack, and I would definitely use it for other projects. So it integrates with almost any data warehouse, and you can use any message queue, including Kafka, Kinesis, PubSub from Google, and etc. Right. But moreover, Snowplow supports data enrichment, so you can enrich your role event data with additional context like country, IP address, and you can even process personal identifiable information with these enrichments. But there are some alternatives to Snowplow to do this. I would name Jitsu, RudderStack as well, but I haven't worked with them closely, so don't have much to say. Let's proceed with the Snowplow. So the pipeline, how does it work? How does it look like? From left to right, you have your trackers on end devices, which would be web, mobile tracker, server-side tracker, pixel, third-party webhooks as well. And then these payloads, event payloads, they get collected into a message queue broker, probably Kafka for me. Then number two, they get validated on a specific schema. Usually an event, it includes a built-in schema in itself, so it's self-describing events. So it's validated. And number three, it's enriched with multiple data providers, third-party, first-party. You can enrich, add something, or exclude or omit something, hash something. And then you've got two kind of streams, good and bad streams. So good stream end up with your data warehouse. You can analyze it, build some sequences, data marts, use it in your calculations, metrics, and etc. And there's a bad stream which, due to a number of reasons, could not land in your data warehouse. Probably it could be a schema validation error, and you from that stream you would find out exactly what is wrong with your data and how can you solve it. So yeah, we'll proceed to the hints also, but as I've mentioned, you would need two kind of streams to ensure all of your data, all of the tracked information is being processed correct way. So out of the box, you get built-in kind of events like e-commerce event, app tracker information, app performance, device browser information. So pretty easy to install and use it out of the box with a well-defined applications and approaches. And in case you want to build something extraordinary or something out of the scope of a built-in capabilities, you would have to create a self-describing event on your own taxonomy. There's an example of a pretty easy and simple event which is self-describing about viewed viewed product. So there's a product ID and product price. That's it. And that's what the event payload looks like. There's a schema and there's a data. And there's a JSON message. Pretty simple. So the setup hints from my side for Snowplow, yeah, let's make it faster because I've got a lot of content. So you would only track relevant information. So you don't need some kind of a garbage, but you need some specific information about your app usage or your customer behavior. So there's an example how you can create a taxonomy and probably create tasks for your Android, iOS teams, web teams to track specific events. Then you would need to use schema registry. It's either Igloo, which is part of a Snowplow ecosystem, or you can just spin up your static website or static server and serve schemas, which is this example is Docker file, which serves schemas as a simple HTTP server, right? So you would need to handle both good and bad events. That means you won't end up in a situation when a portion, but possibly a large portion of events are omitted and never end in your destination due to various reasons like problems with your schema validation, malformed messages, missing data, and etc. So you would need to capture bad streams as well and fix problems timely. Another thing I would suggest you to do is to assign app tracker information. I do have a single table in my Snowflake database for all the events from all the devices, all the trackers, and to distinguish between them, I would just have a specific metadata, which is the tracker namespace, the app it runs on, tracker version, and website application identifier. That's how I identify the root cause or something is wrong with this specific application. So I can identify whom to talk to from web team, for example. Then using Snowplow Micro for debugging purposes is essential before you deploy to production. That's the way you can test everything and ensure all the events and payloads and data is relevant, is available for analytics, and it contains all the necessary information in it. So that's the way you debug your code, your event tracking. Then you would set up a monitoring and alerting. So it's pretty easy with StutsD or standard output, capturing metrics, which is written every 10 seconds. So I would say that it's pretty easy to use with the Prometheus and Grafana dashboard as well. So you always keep track on what's happening with your pipelines. Right, let's wrap up this section, data ingestion. So we have this data streaming enabled, which allows the near real-time and event-driven applications with Debezium connectors and Snowplow and tracking. Then it's arbitrary number of events supported and tracked amongst web and mobile applications. So you always capture relevant information about what's happening with your product. And then third-party event dependencies are reduced by leveraging open source software. It results in tremendous cost savings. This really is. Let's proceed to the section number 3, data transformation. And in this part, I've already mentioned I'm using Snowflake database data platform, but before I made this decision, so I was thinking about how do I choose a data platform? And I first focused on the business needs. So what are we going to achieve? What we're going to build? Name issues you currently face with. It could be performance issues. It could be concurrency issues. Then you define a list of criteria to compare. And then you run a series of proof of concept with a short list of vendors, providers, platforms. And then you make a decision and perform a transition, a smooth transition, and you measure success in the end. So let me give you an example of one of the cases I've had and performed. So why are we doing this? The reasons: we've got performance issues, which results in dashboards lagging, which results in multiple queries run at the same time, multiple users trying to query database and get results. Some of these queries are non-optimal, taking a lot of time, taking a lot of compute resources, so concurrency issues. And then it's about paying for a database 24 hours, 7 days a week. So all the time, you just pay for your data warehouse flat rate. But in case you're not using this extensively, why would you pay for it all the time? So you would probably want to pay on demand rate. Then it's about time to market and product velocity. Like I needed a list of complicated features supported, like semi-structured data, like hexagons, H3 libraries, geospatial data, etc. And then I would want an access to ecosystem, like data sharing, like buying data sets from providers, easily integrate it and use it. And last one, but not least, growing resilience to migrations and skill sets. So simplifying pipelines, simplifying tools used, using a single tool instead of 3 or 4 different tools, programming languages, and frameworks is better. It's easier to find a relevant person to do this. Right. So what to consider? The list of criteria is performance and scalability, feature support, security, maintenance efforts, integrations, pricing model. So I've done my homework, I've done my preliminary job, and I've shortlisted Amazon Redshift, I've shortlisted Snowflake, Databricks, ClickHouse, and I've compared them for these criteria and written this down in a small short version with this matrix, with this lights, green, yellow, orange, or red, whether it's good or bad. So that's just my exercise, my background with this specific case, with this specific inputs and requirements. And I've ended with the Snowflake migration. So I completed Redshift to Snowflake migration, and it gave me a lot of benefits and improvements. So just to name some of them as performance, separated compute and storage, which is awesome. It's auto scaling, so scalability, unlimited scaling, almost unlimited. So have multiple virtual warehouses dedicated to its own purposes, like extract, load, transform, BI tools, users, continuous integration jobs. So, and it's every sort of like performance tasks, jobs are done with their own data warehouse, like virtual warehouse. Then it results in a concurrency, so it's just unlimited, so handles really well, handles workloads, and a cost efficiency. So since Snowflake is the pricing model is about the credits you consume, so the amount of compute power you use and storage. So the instant cost savings compared to Amazon Redshift was about 30 to 40%, like an instant after the migration is finalized. And moreover, I'm just going to mention a lot of advanced features supported, like semi-structured data, variant data type, external tables, then multiple built-in functions like geospatial data, H3 indexing, and that kind of, etc. So with the Snowflake, I use DBT for data modeling, and it really rocks. So DBT is I would say a killer feature. You would totally want to use it if you're not already. So here's the reasons why. Name it modularity. You can reuse code. You can create reusable SQL queries. Everything is defined with declarative select queries, which are templated. Second is version control. So you would treat it like a repository. You would treat it with the whole span of software engineering approaches, like pull requests, code review, automated testing, continuous integration. That's it. There are testing capabilities being built in, so multiple tests out of the box, and hundreds of tests can be incorporated with the installed modules. There's a documentation, and I would mention it as this code based documentation can be then used by your language models. So you would want to query a data warehouse. You just use the manifest file from DBT to allow your model, large language model, to identify which columns and which tables are there and how do they relate to each other, right? So it's data lineage, it's scheduling, running multiple different jobs, and it's really wide, really rich integration features. So works well with Snowflake, Redshift, BigQuery. The time I was transitioning from Redshift to Snowflake, it took me a couple of weeks to amend and test everything, amend the dialect thing in SQL. There are some dialect differences, but the code base, it remains the same thing, just running almost the same code, well, conceptually, and getting the same results in a new database, which is perfect. Right. We've got Q&A session at the end of this. Let me finish in 15 minutes, I suppose, and we've got 15 minutes for a Q&A session. Right, I will watch it and read your questions. Right. So just to give you an example of DBT artifacts, it's a large JSON file. I'm just focusing on a number of columns from a specific table, but you can see that each column has its own description, data type, constraints. You may use the reference integrity things. So that's the perfect input for your language models to create queries automatically based on your natural language. So there are multiple tools like Open Metadata tool to discover these dependencies and to show depicted on the fancy UI, these lineage and tags directed at cyclic graphs of models. But here's the perfect input for your language models to create perfect queries for your data warehouse based on natural language. Perfect feature for business users who don't want to dig deep down into SQL. All right, DBT code is self-documenting. Okay, one more thing about data transformation is about using Kafka single message transformations. I'm doing it for sensitive data handling, namely PII. And what I'm doing is masking hashing data before it lands into data warehouse. So in our data warehouse, there is no sensitive data at all. So it's either excluded or hashed, masked, and then loaded. So no sensitive data in data warehouse. It's done by Kafka single message transformation on the fly. It's done with the Java code, in fact, but it's pretty simple, and these Java code can then be compiled and used with Kafka Connect properties selectively to specific topics. Here's the example. Here's an example. So there's a simple Java code with new additional fields I would want to compute. So it's hash. It's then country based on phone number, it's email, domain, and its Boolean flag is avatar added, for example. And then you would compile this Java code. You would test it first, you would compile and end up with the binary file. You add it to your Kafka Connect cluster, first picture. You then use it as a property with the Kafka sync connector. So there's a transform which originates from this class, Kafka users. And please use it with the predicate users. So we apply it to specific topics, which is core user topics. Right. Pretty simple, but very efficient and elegant solution to this task. All right, so the results, we're achieving full control over data flow and transformation with DBT and Kafka single message transformations. It turns out data is available real time to less than 1 hour, is available in data marts, enriched, aggregated, and ready to serve, to be served to BI tools, data science models, and etc. And then it's self-documenting code. So everything we do is a version controlled, is self-documenting code, and it's got full scope of metadata available for further using. All right, and then we end up with the complete data ownership, zero processing outside company perimeter. The last one, the fourth section is about data operations. Let's get it.
Artemiy, sorry to interrupt you, but you had a question. Bilal asked a question. If you want me to read it or you're going to go through it.
Yes, please read it.
So Bilal says to do data modeling, you need to know the incoming data very well so that you can model it. What if the data is coming? What if the data that's coming is not very structured? So that's his question. What if data that is coming to us is not very structured?
Yeah, I got it. So if it's not very structured, then it's got semi-structured nature in it. It's flexible. It could be done due to several reasons. That's why the source database would want to keep its data flexible. So they would want to add a column, change column name, column data type, do it easily. All right, MongoDB supports this, so it's semi-structured database. But in terms of data warehouse, in terms of using these data, you can replicate it as is. So there could be nested structures. They could perfectly fit into variant columns or similar columns types in other databases. Almost any database supports nested types. And then when you end up with the specific business requirement, you would want to get specific information from this flexible semi-structured data. You would get it. You would parse this data on the specific rules, and you would create a data mart on this data. But you need a specific number of requirements. But unless you have it, you just store and keep your data flexible way. There's no problem in it. That's it. So I hope I've answered your question.
Thank you so much. Yeah.
All right.
And okay, so Bill also asked, then after loading the unstructured data into the data warehouse, let's say ASAP, then we should structure it and model it, question mark. So he asks, after we load the unstructured data, then we should structure it and model it.
Yeah, if there's a specific case for it. So you have to model your data in case you have an ideal. How would you use this data? If you don't have, you just store it. That's the principle of data lake, I suppose. So you just replicate your data, and once it comes, once the idea occurs, so there's a specific use case. Let's do it like the way A, B, C transformations. We can do it. So that just there's no problem in storing this data or modeling if you have a specific requirement, right?
Thank you so much. Bilal is happy with the answer. Thank you so much once again. You can proceed.
Oh yeah. Now I see the Q&A once I've exited.
No, but it's okay. If there are any questions,
all right,
I'll let you know.
So let's proceed with the last part, data operations. I would suggest you to use dev containers. Every time you work with a new project or new environment, or you would need to reproduce this environment with the other team members, I suggest you to use dev containers. Dev containers are ways to create reproducible environments, which has pre-built, pre-installed tools in it, pre-configured tools. So I would not really read this. I would just show, give you an example of this dev container. So there's a Docker file, which is based on a Python image. And on top of this Python image, I install utilities like curl, git, and then Kafka cat, probably anything else. And then I install dbt, being a Python package of a specific version. So dbt is installed as a Python version, and then I set an environment variable. So dbt profiles directory is the current directory. That gives me an image which could be built, and I can run a container from this image, from this Docker file. And the most notable thing about it is that this dev container can be used on any platform and by any team members. So this is reproducible, and moreover, it's built-in feature in Visual Studio Code. So you have to click one button to spin up a fully functional environment with all the utilities installed, with the specific version, languages, dependencies, and that's really amazing. I'm using this feature for a couple of years already. I'm just doing it to, like, just imagine a new data scientist you've hired yesterday is able to do his tasks today with one button click to spin up the fully functional environment and proceed with his tasks, not just installing packages, coping with dependency hell, and that kind of stuff. All right, a short demonstration. So we've got this rebuild and reopen in container. Give it a couple of minutes to run to create a container from this image. And then, boom. You can also install extensions, specific extensions like Java, like Python, like dbt power user. And yes, you end up with a fully functional environment. So you can get version, you can get dbt of a specific requirement, a specific version with a specific connector. Right. Second thing is operations is about signaling. I wanted to talk about it more. And with the signaling capabilities, you can resume, pause, trigger snapshots, incremental blocking snapshot. You can manage offsets, manage configurations, or even perform your custom actions. Let me give you an example of Debezium single collection snapshot. So if I want to replicate the whole collection from scratch, do it once again, or there's a gap, or there's no history for it, I would just trigger a Kafka message with a kcat utility. So there's a simple bash script, two variables, connector name, data collection, and I'm creating a message and submitting this message, publishing this message to a specific topic. Debezium signals MongoDB. That's it. Very simple. And this action triggers incremental snapshot of a single collection. But you can go further with this. You can execute multiple collection snapshots just by creating a specific bash script, by doing it with the for loop, for example. And then you can execute single collection snapshot with conditions. For example, a date range. You've discovered that a specific date range a month ago, a year ago, it has some differences with the data between data warehouse and data source. So why would you replicate all the data? It could be tremendous amount of data. It could be large collection. You would need to sync a specific period of time. So you provide a condition with the date range, or even condition with the list of object IDs or keys or primary keys, for MongoDB and for Postgres databases. So scripting is really easy, and it's a really powerful feature with signaling with Debezium. So that means signaling means that you can trigger arbitrary snapshots on demand. So you would replay your data at any time and any with any conditions and filters supplied. That's perfect. Third thing I wanted to talk to you about is deduplicating log entries. So since the Debezium is the log replication change data capture, you would sometimes want to end up with a snapshot, like a latest row entry by key, and you would not want to keep the stale or outdated data, the previous states, the history track. You would need to trigger delete command. So Snowflake, in Snowflake, I do explicit way with this fancy DBT macro, but there are databases like ClickHouse, which has this capability built in. It's got this replacing merged tree type of a table, which does it the same thing in background. So here's an example for DBT macro, which is templated, and I run it once a day, once a week in the night to ensure my tables are up to date and there's no large tail of outdated rows, right? Fourth thing is about operations, is ensuring your code, your pull requests, your change requests, they pass a certain amount of automated testing. So you would need to, you would probably test if the code is working, if it runs smoothly, and second thing, if it works as a desired with the tests scenarios passed. All right, it can be configured to the GitHub Actions or in any other CI tool. And then I would suggest you to configure Slack or Telegram alerts messages on any kind of event or error or incident you face with. So whether it could be source freshness issue, data theft issue, or your Debezium connectors fall down. Right. So the results with the operations approach, it's easy and maintainable to run certain operations on demand. It's really prone to scripting, so it becomes fancy and easy to trigger this, especially when using the dev containers with pre-built and pre-installed utilities like Kafka, Cat, JQ utility for parsing JSONs, and etc. So wrapping up for today, we've been covering ways of building solid foundation for AI applications. I've mentioned a number of AI opportunities I would really like to implement in my company. So, but to build this, to start with AI applications, you would need to have your solid data foundation. So in terms of ingestion, near real-time and event-driven applications allow multiple opportunities. So tracking events amongst cross-device, cross-platform is essential for your customer behavior and analysis and reacting and creating some follow-up actions. And then ends up in the third-party vendor dependencies reduced. Then it's about data transformation. So achieving full control of a data flow with DBT, with Kafka, single message transformation. And it gives us almost near real-time data availability for most important data marts, so can be served real time. So gives you a lot of opportunities to take action in the real world, like prevent fraudulent transactions, to balance your equilibrium, demand, supply, to fair distribute orders, and etc. So self-documenting code and full scope of metadata available. And in terms of data operations, as I mentioned, easy and maintainable, repeatable actions, scripting, and wrapped into dev container. All right, so that's it from my side for this talk tutorial. Now I'm ready to answer your questions if you have any. And it was pretty nice and interesting experience for me. Thank you for being attentive, listening. Yeah, I'm happy.
Artemiy, thank you so much. Thank you so much. This was really, really useful and yeah, interesting for all those looking to take advantage of the AI applications and make some usage of them. So if there are any questions,
All right.
I'll read them through. But yeah, no one is okay. Let's just wait another minute in case someone has something to ask. If not, then we have a break and we'll see you back here at 11:45 with another presentation. I mean, people are slowly leaving the presentation, so I guess we can finish. Thank you so much once again, and see you all.
No problem. Thank you.
Goodbye.
Thank you and bye. Hope you enjoyed.